Hi, Charles. Thank you so much for
How's it
joining
going,
us.
Tom?
I'm good.
Oh yeah,
How
no
are you?
problem. I'm doing good. Can't complain. I'm just gonna share the link for the Dropbox in the file again. I think we're gonna finish up with the notebook titled Code Challenge 3-11-22. And also right now, since it's just me and you, Tom. So if there's any like particular questions you want to ask me about anything we've gone over in the past, or if there's any like interview questions you've encountered and want to discuss, we can do that too.
Sure. Maybe I'll have some question at the end. For now, I will just follow
Sure.
you.
All right, no problem. All right, so just let me know once you've gotten the notebook open and you're ready to go. It's like a Code Challenge 3-11-22. All set, or you need another minute?
I just need a second. Sorry.
Sure.
Sorry, I don't know why my computer is a little bit slow. I will get there shortly.
Oh, all good. All good.
I'm all set.
Oh, okay. All right. So if you follow the link, we scroll down to Python section. Actually, let me share my screen for the sake of the recording. All right. So if we scroll down, we're gonna finish up with these two Python questions. So we click on the first lead code link. Once it loads, all right. So this question is called max consecutive ones. So we're given a binary array, just an array of ones and zeros. And what we want to find is we want to find the maximum number of consecutive ones in the array. So if we look at example 1, We see we have an array nums 1, 1, 0, 1, 1, 1. We see over here we have 3 ones. That's the longest consecutive sequence of ones in this array. So we return the length of that sequence, which is 3. And we see, for example, 2, we have a sequence here, nums equals 1, 0, 1, 1, 0, 1. We see in the middle, we have this sequence of 2 ones. That's the longest contiguous sequence of ones. So we return the length of that sequence, which is 2. So yeah, we just want to write some code that's going to go through this list and find the maximum consecutive length of ones. And are there any questions in the problem statement? If not, I think we can work on this let's say we'll work on it until 10:30, 12 minutes. So let's think of a solution, consider how our approach, maybe get some code up and running, and we'll come back and discuss the solution. And again, I'm not sure who was here last time or not, but I gave a hint of this problem belongs to a class of problems called left-right pointer problems, or double pointer problems, 2-pointer problems. And it's a problem solving technique for a few coding challenges. And that is my hint for this one, is that you'll need 2 pointers to solve this one. If there's any questions, feel free to speak up, message in the chat. But if not, we will meet back at 10:30 to discuss our ideas.
Okay, I will give it a try.
Sure. And again, this is just me and you. If you want to talk anything through, or discussing ideas beforehand, feel free to speak up.
You can
Just let me refresh my memory a little bit and never get back to you shortly.
Sure.
Yeah, I had some idea, but I haven't. I just put some code in. I didn't went through it, whether it's work or not. Let me try it. Okay, can you hear me? I cannot hear you. Is it because of me? Can you hear me? Hello? I cannot hear you.
Hey, Charles, there's no sound coming from you.
Can you guys hear me now?
Yeah.
Oh, okay. Sorry about that. So like I was saying, I'm not sure how much. I'll just start back. So the algorithm, we start off. We with our right pointer, our left pointer is at 0, our right pointer is at 0. We observe the first element to be 1. So the longest sequence we've seen So before this point was 0, and now we see the sequence of length 1 of just ones. So we're going to update the length. And the way we update the length is we look at the right pointer, and we're going to look at the left pointer. So we update our right pointer to point to +1. So R is now equal to 1, and L is equal to 0. So the way we get the length of the sequence, we subtract the index of the right pointer from the left pointer, right? So we have 1 minus 0, and that's just going to be length 1. And that's how we update our max length. Then we iterate to the next element, and it's also a 1. So when we see 1, we're going to update our right pointer to point forward 1. And then we're going to do the same thing. We want to say, look at the difference of the L and the R. So now L is still 0, R is going to be 2. So we saw 1, so we increment it. So what we do, we then take the difference of R minus L and see if that's bigger than our max length. Since R minus L at this point is 2, and our max length seen so far was 1, we're going to update max length to be 2. All right, so then we look at the next element. Our next right pointer is pointing here now. We've seen a 0 now. All right, so now what do we want to do? Since we've seen a 0, we no longer want to consider this sequence. So at this point, what we want to do is update our left pointer. Because our left pointer was pointing over here. So now we want to somehow have them both of our pointers to point to the next index over here. So what we're going to do is we want to say, again, like before, we're going to update our right pointer. We're going to add 1 to it. So our right pointer is now going to become 3. And what do we want to do with our left pointer? What we're going to do is we're going to have our left pointer point to our right pointer. So we're going to update the left pointer to be at index 3. And what this does is effectively sort of resets our count, right? Because now when we have both of them pointing to this third index, we have R and L are both 3. So when we subtract R minus L to find the longest length, it's just going to be 0, right? And if our max length already observed is greater than 0, then it's not going to do anything. It's not going to change anything. So that's why we increment our right pointer, and then we have our left pointer point to the right pointer. Once we've seen a 0, we've broken the consecutiveness of the ones, right? So we don't want to consider anything over here anymore. So we want to have our left and our right pointer point to past the 0. And now we can continue through our loop, and we'll see that we'll be able to find this next sequence of ones. So now we're here. So we're going to, since it's a 1, we increment our right pointer to be 4. So now this is going to be 4. And what we're going to do is now we're going to check to see what the max length is. So we do that by subtracting the right pointer from the left pointer, right? R minus L is 1, but the max length is already seen so far is 2. So we want to take the max of those values, right? The maximum is just the max length itself. 2 is greater than 1. So now so far the contiguous sequence we've seen so far is this length, is length 1, and it starts here, right? And this is why it was important to update the left pointer, because if we didn't update the left pointer, then still be pointing back at the 0th index. And then when we did our arithmetic, we'd find this length of sequence 4, which is invalid, right? Because it's 0 cutting out the consecutiveness of the ones. So that's why we had to update our left pointer to point past the 0, right? So we just continue through. We're going to say, okay, well, our right pointer is still less than the length of num, so we increment by 1. We see that it's the value of that value is a 1. So now R becomes a 5. Now R becomes 5, and we do the same arithmetic. We check to see what our max length is so far. We take 5 minus 3, the right minus the left. We see we get a value of 2. That's equal to our max length of 2, so we don't overwrite that value. We just keep it on, right? And so we continue on. So now we are here. What we do is we see a 1, so we increment the value. So now our right pointer is past the length of the array. So we're going to terminate after this last step. We see R, so R is 1, we increment it. So R is now 6. And again, we do the same arithmetic. We do just the right minus the left to find a new length. And we see that right minus left is 3. And since 3 is greater than 2, we overwrite ML. So now ML is no longer 2. It's now 3. And like again, since right now points past the length of the list, we aren't going to continue on anymore. The loop is terminated, and we just return the max length. So the max that we ended up after running through this algorithm is 3, and that is the correct answer here. The max contiguous set of ones is length 3. So what we're going to do now is we're going to just code this up now that we've gone through step by step the process. So the first step, like I said, we want to set our pointers. We want to say we have a left pointer, and this is just some like Python syntax. You can do this all in one line. Our left pointer is going to be equal to our right pointer. It's going to be equal to, we also want to initialize a max length. It's going to be equal to 0, right? We start with the algorithm. We have the left, the right, and the max length are all equal to 0. And then what we want to do next is we want to do this loop. We want to loop through the array and apply the logic we talked about before. So what we're going to do is say while r is less than length of nums. What are we going to do? Well, before we said, well, we want to see, well, if nums is 1, right? If nums of r is equal to 1, then what are we going to do? We're going to increment r, right? R plus equals 1. And then what we want to do, we say r plus equals 1, and then what we do is we want to check our max length, right? So we want to see if our max length, our new observed longest sequence of 1s is greater than our prior observed sequence of 1s. So we're going to say max length is just going to be equal to the max of max length itself, comma, what do we want to do? We want to look at the right value, the value of the right index minus the value of the left index. So we're just going to say right minus left, right? So we covered the case where r is equal to 1, but what about the case when r is, or nums of r is equal to 0, right? We haven't covered that yet. We want to say else, so if nums of r is not equal to 1, then the only other option is 0, right? So we're saying otherwise, else, we're going to say, you know, nums of r is equal to 0. That's that case. What we're going to do is we're going to increment our right pointer, and we're going to have our left pointer be the same value as the right pointer. So we're going to say left is equal to r. And remember, that was like over here, when we hit this 0, we don't want to consider this sequence anymore, so we increment our right pointer to point to 0 to this 1, and then we have the left pointer also point there, so we can continue on with our loop and finding the longest sequence of 1s. So we said right plus equals 1, we set the left pointer to the right pointer, and that's it, right? And then it's again, whether we encounter a 0 or a 1, we can still just update our max length. But we know if we encounter a 0, the max length is going to be updated. So continue on like this, and then at the end of this loop, once this loop is done running, we've done all the work. Max length now holds the longest continuous sequence of 1s. All we want to do is return max length. And hope I've done everything correctly. Where you want syntax errors, I can try and run this code. All right, as I said, I can try submitting. Okay, wow. All right, so we run it, and we'll just quickly talk about the time and memory complexity. So time complexity is we have a list of length n, and we need to just iterate through it once, right? So the time complexity is just O of n. The space complexity is O of 1, and that's because we only have a constant amount of memory being used. The size of the array doesn't matter for memory because we're only keeping track of the left pointer, the right pointer, and the max length. So even if the size of the array is 1 billion, we're only still keeping track of 3 values. If the size of the array is 2, we're still only keeping track of 3 values. So it's independent of the size of the problem. So that means the memory complexity of this problem is O of 1. Are there any questions on anything we've covered? Any questions on this algorithm or left-right pointer method for solving problems in general? All right, if not, hello Vivian. We are working on notebook coding challenge 31122. If you want to follow along, we're just finishing up from last week. And what we're going to do now is going to move on to the next Python problem we have. So if you follow the second lead code link, it loads. I'll delete my code. All right, so we're going to read the problem statement together. So you were assigned to put some amount of boxes onto one truck. You're given a 2D array box types where box type of I. So we're given a list of lists. Each list is 2 elements long. The first element is the number of boxes that we have. And the second element is the number of units per box, right? So what we want to do is, given an integer truck size, which is the maximum number of boxes that can be put on the truck, we want to find the maximum number of units that can be put on that box. So we're given a truck size, which is the maximum number of boxes, and we can choose any boxes to put on the truck as long as the number of boxes does not exceed the truck size. And we want to return the maximum total number of units that can be put on the truck. So we'll just go through the examples quickly. So imagine we have these box types. So we have one box that has 3 units. We have box type 2 boxes that have 2 units, and 3 boxes that have 1 unit. The truck size is 4. The output is 8, and this is the case because there is one box that has 3 units. So we certainly want to use that, right? And now our truck size is 3. So we can also fit the 2 boxes that have 2 units because we fill space. And once we put those on, our truck size is 1. We have 1 box left. We have one, so we can put on one of this third type of box. And what that sums is we have 3 units in the 1 box, 2 units in the 2 boxes, and 1 unit in the 3 box, and that sums to be 8. We'll go through this example down here. So again, we have box types. We have 5 that have 10 units, 2 that have 5 units, 4 that have 7 units, and 3 that have 9 units. The output is 91, output of 10. So if we can load up all the boxes type 5, so that was 50. And then we can load up all the boxes that are type 3, that'll give us 27, so that'll give us 77. And now we have 2 left. So we can also load up 2 of the 14 boxes, which is going to be 77 plus 14 is 91. So that's why the output is 91. So we can load up all of these boxes, and then we only have 2 spots left. So obviously we want to pick the ones that have more units, and we can only load 2 of them. So we can have, we'll only take 2 of the 4 type boxes, which gives us 14 units. So 50 from here, 27 from here, 14 from here sums to be 91. Are there any questions on the problem statement? All right. If not, I think we'll work until 11:05, 17 minutes to consider this problem. And once again, if there's any questions, feel free to speak up or put something in the chat. And yeah, we'll meet back at 11:05 to discuss the solution.
Any questions on the problem or any thoughts you want to share? All right, welcome back. The solution or thought process or anything you'd like to share? All right. Well, not, we're just gonna go through the question. So potentially the way I walk through this problem with a bit of a hint is we want to look at the boxes that have the maximum number of units because that's what we're concerned with. We want to get the maximum number of units we possibly can. So I really looked through, I searched for the ones with the maximum units and add those to the truck first. So I saw that we have five boxes that have 10 units, so I added those first. And the next thing I saw, the next largest was these 3 boxes of 9 units. I added those next, and the last I saw was these boxes here at 7 units. So I wanted to add as many as possible. And at that point, we only had 2 spots left, so I just added 2 of them. So it was an example of a greedy algorithm. It's where we choose our solution based off what's best at the moment. So we're just going to run through the code. All right. So the first thing is we want to consider, first box is to consider the boxes that have the most units in them. So we want a way of precedenting boxes that have more units, which essentially just we want to sort this list by the number of units per box. So what we're going to do is first things first, we'll say box types. We're going to sort this so that we just iterate through and add the biggest boxes to our truck first. So we're going to say box types is going to be just sorted. And we're going to sort box types. And we're going to say, how do we want to sort it? We want to sort it based off the units, right? We want the boxes that have the most units to be at the beginning of the list, and the boxes at the end of the list will be the least units, because we want to consider the boxes with the most units first. So what we do is we say our key, how we're going to compare them, is just going to be to we'll just do a lambda function real quick. And we want to compare by units, right? So the unit value is the second value in the list, index 1. So we say we want to compare based off of the units, which is this lambda function x and 1. And then by default, the sorted, built-in sorted is going to return from smallest to largest. Oh, you can revert that by just using the reverse keyword. So we say reverse is equal to true. So what it's going to do is box types can get overridden with box types, but now they're going to be in a descending order with the first element being the number of boxes that has the most number of units. All right. So next thing is, well, what do we want to return from this function? We want to return the maximum amount, right? So we like to store that in a variable. So I'm also going to just initialize amount to 0. That's just going to be the variable we return at the end. So we'll do our work and we're going to return amount. That's fine. So what we want to do is we want to keep on adding as many boxes as we can while there's still space in the truck, right? So we're going to iterate through the list, and if there's space in the truck, we're going to add boxes. If not, we're going to break out this return amount, right? So what I'm going to do is I'm going to say I'm going to call it num boxes and units per box in box types. The first element of this list was number of boxes. The second element was the units per box, so I've named them accordingly. What are we going to do? Well, first we want to figure out how many boxes can we pack, right? So imagine we have like this case here. We had 5 boxes with 10 units. So imagine our truck size was, instead of 10, it was 4. But we can't just pack num boxes into our truck. We first need to check the capacity of our truck to see how much space we have left. So really what we want to do is, since we want to return the boxes we want to pack is going to be equal to the minimum of either the truck size or the number of boxes, right? If we have 3 boxes and the truck size is 4, we want to pack all of them. But on the other hand, if the truck size is 3 and we have number of boxes is 4, then we can only pack 3 of those boxes, right? So we want to find the minimum of those 2 values. So we're going to make a variable called boxes to pack. We're going to use the minimum of truck size. and num boxes. All right. So now what we want to do is now we found how many boxes we can even add. What we want to add is the amount of units we're adding, right? So the amount of units is just the number of boxes we're going to pack times the units per box, right? That was the raw amount of units. So all we're going to say is amount plus equals boxes to pack times units per box. Units per box. All right. So we add this amount, right? We put these boxes into the truck. So now the last thing to do is to update the amount of space left, right? We put in K units. So then we want to subtract K units of space from the truck. So what we're going to say is truck size. What do you call it? Truck size minus equals boxes to pack. All right. So now we've put in our boxes, we've recalculated the truck size. The last thing to do is we only want to continue this loop while we have space left in the truck, right? We can't add to a truck that's already full. So the last thing to do is we want to check whether or not we should continue packing. So the way we can do that is check the truck size. So all we want to say is like if truck size is equal to 0, meaning there's no more space left, we want to break out of this loop, right? We're going to continue adding these boxes in the according order until there's no space left. All right, and that's about it. So just to reiterate over the problem is, we first realized we want to sort the boxes by the units per box. We initialize an empty value amount, which is going to be what we want to return from this function. And we're going to iterate through. For every element in our list, we want to see how many boxes is it possible to pack. We take the minimum of the truck size and the num boxes. And once we get that value, we say the amount of units added is equal to the number of boxes we can pack times unit per box, and we add that value to our amount value. Then once we add the boxes on, right, we need to then update our truck size. So we subtract from the truck size the boxes we packed. And then the last thing we just say, if our truck size is 0, meaning we've packed everything we can, there's no more space, we're going to break out of this loop and return them out. All right, so barring any syntax errors or anything, this should run. All right, and submit. And we see it runs. And just talk about the time complexity and space complexity. Time complexity, since we're sorting, the absolute theoretical minimum for a sorting algorithm is O of n log n. And as far as space complexity, we have O of 1 extra space because we're not making any more data structures, right? All we have is a single variable amount that we've initialized to store the answer, right? So there's no extra space, it's O of 1 extra space for this problem. So are there any questions on the algorithm, the thought process, or anything related to this problem?
No.
All right. If not, then we're going to go on to this week's notebook. So if we go, we're going to, it's titled Code Challenge 3/15/2022. Open it up. And we're going to start off with a probability question. So we'll read the statement together as always. So 3 friends in Seattle, they each tell you that it's raining, and each person has a 1/3 probability of lying. What is the probability that Seattle is rainy, assuming that the likelihood of rain on any given day is 0.25? So this is like I think a pretty standard probability question you could really expect to see on an interview. So if there's no question, are there any questions on the problem statement? All right, if not, I think we'll take till 11:25 for this problem. Then we'll come back and we'll discuss our thought process and solutions. And once again, if there's any questions, feel free to speak up or message in the chat.
I need to drop off after this question. I will try to give a try and just for now. Yeah, thanks.
Sorry?
I think I need to drop off after this question, but I will
Oh, okay.
give a try.
Okay, no problem. No problem. Well, if you need to leave even earlier, just if you want to go over the problem earlier, just speak up and go over it earlier, just to like accommodate your time.
She just left, Charles. I can't hear anything.
Sorry. I don't know if you want to stop the YouTube recording, but I can remain on in case anyone pops in. But
Can you give me back hosting? I would have to log
oh
in.
yeah. How do I give back hosting?
In the picture in the right corner, upper right corner, there's like 3 dots. If you select it, there should be a drop down option to make host.
There's a mute my audio, stop video, choose virtual background, choose video filter, pin, hide self view, add profile picture, and rename option. I don't see a host option. Wait,
Let me double check and see.
if I share my screen actually, just so you can see exactly what I'm looking at. Where did it go? Oh, I just can't see it. It disappears.
You know what it is? Vivian logged in as this login user, so we're probably just going to have to end it.
Oh, she has host options?
Yeah, it had signed me out, so I don't have access to anything. Vivian did when she logged in.
Okay.
So we're just gonna have to end it. I think it should be fine.
Okay.
But we'll talk later.
Okay, sure.
All right, bye.
All right, bye.